Start the recording. Okay. Any question regarding the problems? Okay. In this week, we have two problems. First one is a block A and attached rod have a combined mass of 60 kilogram, and they are confined to move along the 60-degree guide here. You can see this is the angle under the acting of the 800 Newton this force. The uniform horizontal rod has a mass of 20 kilogram. This rod has a mass of 20 kilogram and is welded to the block at B at this point. Friction in the guide is negligible. Compute the bending moment M exerted by the weld on the rod at B. We want to calculate the bending moment here at this point B. If it was a static problem, easily you can plot the free body diagram. I mean, you can cut the rod from here and you will have two reaction forces and one moment reaction. And also we have the weight for this rod, and easily you can calculate the moment, which is equal to the mass times by the arm, which is 1.4 this length divided by 2. So easily in the static problems you can calculate the moment reaction at point B. But here in this case we have a dynamic problem. I mean, this system is moving with some acceleration in upward direction. As you can see, we have this force 800 Newton. Also we have the weight for the system, which is 60 times by G, because the weight is equal to the mass times by G, and mass for the total system, for the whole system, is 60 kilogram. So first you need to obtain the acceleration, because this is a dynamic problem. And also the motion in this case is a pure translational motion. As you can see, this system is moving in upward direction. There is no rotation, and this is a pure translational motion. So easily you can write the force equation in x direction, and x is this axis. We assume that x is an axis parallel to the inclined surface. So if you write the force equation in x direction, we will have this 800 Newton force. Okay, we have the weight component in x direction. The weight component in x direction, you know, it's equal to weight times by cosine 30, which is this angle, or weight times by sine 60, which this angle is 60. Okay, so you can write the force equation in x direction, and it's equal to 800 minus mg times by cosine 30, and it must be equal to m times by the acceleration in x direction. Okay, so when you write the Newton's second law in one direction, you can easily write the Newton's second law in each direction. As you can see here, we use in x direction, and in x direction, because the motion is in x direction, so we will have this acceleration. But if you write this force equation in the perpendicular direction to the x, in the right hand side we will have 0, because there is no motion in this direction. Okay, from this simple equation you can easily obtain the acceleration, which is 4.84. This is the acceleration of the whole system, this block and this rod, which they are moving in upward direction with the incline, on the incline with angle 60 degree. The next step, we need to obtain the moment reaction here at this joint B. So we need to plot the free body diagram for this rod, and if you plot the free body diagram, we will have these two reactions, as I told you. force reaction and one moment reaction. We want to calculate this moment. We have the weight of the rod, which is 20 kilogram times by g. And also we have this acceleration. This is the difference between this problem and a static problem. So in this case, we have the AX, or the acceleration. Now we can write the force equation or moment equation to obtain the moment. We don't need to write the force equation, because here we have AX, the acceleration. So only we can write a moment equation to obtain M. So if you write the moment equation here, you can see the moment equation about this point, which is point B. We will have the moment equation about B is equal to, because this is a translational motion, there is no angular acceleration, so it's equal to 0. But in the right hand side, because you are writing the moment equation about another point other than the mass center, so as I told you, we will have MAD. So this term is an additional term that we will have in the right hand side. So the moment equation about point B, we have two reactions. These two reactions at point B, both of them pass through this point, so they don't have any moment. Only we will have the moment due to this weight, which is 20g times by this length, which is 1.4 divided by 2. And also we have the moment reaction. So you can see we have moment M, which we assumed it is in clockwise direction. The moment due to this 20g force is again in clockwise direction, and it must be equal to, as I told you, MAD, which here in this case, AX, we will have two components. You can see this is the vertical component and this is the horizontal component. The horizontal component will pass through this point, so we neglect this term, and only we consider the vertical component in the acceleration, which is AX cosine 30. This is cosine 30 and this is AX, and times by M, which is the mass, 20 kilogram, the mass of the rod, and times by D, which is 1.4 divided by 2. But if you look at here, we have one negative sign. And the reason that we assume one negative in this formula is that the acceleration will create a moment in counterclockwise direction. This AX cosine 30, if assume this is a force, the moment due to this force about point B is in counterclockwise direction. And if you look at to the left hand side of the equation, you can see in the left hand side, we assume that the clockwise direction is positive. So counterclockwise direction, this term will be negative. So easily you can substitute the values, and from this equation you can obtain that M is equal to minus 195.8 Newton meter. Here again you can see we find one negative for the moment. What does it mean? It means that our initial assumption is not correct. Here we assume that the moment M is in clockwise direction, but when we solve the equation, we obtain that the moment is negative. It means that M will be in counterclockwise direction, okay? Because we assume that clockwise direction is positive. You can see when you determine a negative value for your moment, it means that this moment is in counterclockwise direction, okay? Clear? Any question from this problem?
No, sir.
Okay. Okay, thank you. So the next problem here, we have a cabinet which is located on a trailer. Determine the value of P which would cause the cabinet to begin to tip. What coefficient mu s of static friction is necessary to ensure that tipping occurs without slipping? So this case, again, it's a pretty simple problem. You know, when you exert the force P in the right direction, the acceleration will be again in the right direction. So if this cabinet will start to tip, it will rotate about this point A. Yes, because the acceleration is in right direction. So if this cabinet want to tip, it will rotate about point A. So we can first obtain the acceleration for this case, for this problem, and we can obtain the P. So for this purpose, we can write the force equation in horizontal direction. We assume that this is axis X, which the positive direction of axis X is to the right. So summation of the force in X direction must be equal to the mass times by the acceleration X. This mass is the total mass of the cabinet and of this trailer. So we can obtain that P is equal to M times by AX. So the acceleration in X direction is equal to the P divided by M. So this system will move with an acceleration of AX, which is P divided by M. But now we can plot the free body diagram for this cabinet and assume that this cabinet is on the verge of tipping about point A. For this purpose, if you plot the free body diagram, at point A, we will have one normal reaction, one friction force. At point B, again, we have one normal reaction and one friction force. Also, we have the weight of the cabinet, which is 50 kilogram times by G. We have the acceleration AX because the cabinet and the trailer are moving to the right at the as a whole system. So the acceleration AX will be inserted to this cabinet. And now you can write the force equation and moment equation to obtain the reaction forces and the acceleration AX. If you write the moment equation about this point A, here you can see FA and NA, because both of them pass through this point, they don't have any moment about this point. If this cabinet was on the verge of tipping, it means that this connection will be detached and the reaction force NB and FB will be equal to 0, as you can see here. So we neglect FB, NB, FA, and NA in this case, and only we will have the weight, which creates some moment about the point A, and the moment of this weight is mg times by its arm, which is 0.4. Here you can see this is the arm and it's equal to 0.4. So we will have this term nb times by its arm. As I told you, this is equal to 0 because nb is 0, and it must be equal to mcaxd, again because we are writing the moment equation about point A. If you wrote this moment equation about the mass center in the right hand side, it was equal to 0. But here we have MAD because we are writing another point other than the mass center G. So we will have mass times by the AX, acceleration times by D, and D is this distance, okay? And it's equal to 0.6. Now you can substitute and obtain the exact value for AX, and it's equal to 2 times by G divided by 3. This is the acceleration for the system when it's moving to the right. By assuming that this cabinet is on the verge of tipping about point A. Okay, so this is the acceleration. Now we can obtain that P is equal to 392. If you substitute in this equation, substitute AX is equal to 2 times by G divided by 3. We have the mass, which is 50 plus 10, and it's equal to 60 kilograms. So it's equal to 60 times by, here you can see 60 times by 2 divided by 3 times by G. And this is the external force P. Now we can obtain the required friction force. Again, if you write the force equation in x direction for the cabinet, in this free body diagram, you can see FP and B are equal to 0. So in x direction, we only have this force FA, and it's equal to mu s times by NA. Clear? This is the friction force. It's equal to the coefficient of friction times by the normal reactions. So you can write mu times by NA is equal to MCAX. The AX is obtained here, 2 times by G divided by 3. MC is the mass of the cabinet, and FA is mu times by NA. And NA is equal to MC times by G. If you write the force equation in vertical direction, we will have only NA and MG. It must be equal to 0. So NA is equal to MG. And finally, we can substitute and we can conclude that mu must be equal to AX divided by G, which AX is 2 times by G divided by 3. So we can conclude that mu must be equal to 2 divided by 3. And this is the minimum quantity for mu. I mean, if mu was more than this value, again, we have the same assumption. And the tipping will be occurred, and this system will move with the same acceleration. Okay, any other question? Is it clear? No question? If you don't have any question, we can wrap up this session. Otherwise, I will. Okay, thank you. Okay, thank you all. And so we can wrap up the session and have a good weekend. Stay safe and thank you again.